This lesson is over inequalities. Let's begin by discussing a problem like this. All right. Well, first let's talk about the inequalities. I guess would be the best thing to do. What is an inequality? Well, we know that equal sign means that two things are equal. So that's what we call an equation. An inequality would be something with a sign that looked like this. A less than sign, or a greater than sign, or even less than and equal to, or greater than and equal to. These are considered inequalities. Equation, inequality. Equation, inequality. All right. So an equation, x is equal to 9. That's an equation. It means that this unknown variable is equivalent or equal to 9. An inequality would state this: x is less than 9. Now, these are different. What is the value of x? 9. When x is equal to 9, the value of x is 9. But when x is less than 9, that's a little bit different. That means that 8 could be x, and it would make the statement true. 7 could be x, because 7 is less than 9. 6 could be less than 9. Notice there's a lot of possible answers for x that would make this statement true, but there's only one that makes this statement true. 9 is the only thing that is equal to 9. But many numbers. And so when we deal with inequalities, we always show the answers using a range or a number line. And we do it this way. We say, let's say that's 9. Here's 10, 8, 7, and so on. Okay, 8 is less than 9. It means that it doesn't equal 9 because 9 is more than x, but any number below 9 is a good number for x. So we put an open circle on 9 and we point to the left. Now, how do we check our answer? Well, we choose a number under our bar. Let's say 0 is down here somewhere. 0 is less than 9. True statement? Yes, it is. 0 is less than 9. And so that's how we know we've graphed this correctly. And so this number line depicts the value of x is less than 9. All right. Now, what if we had, let's change my color here. What if we had something like this? Let me scroll down. Oh, sorry about that. Wrong one. Let's see here. Okay, what if I had a number line like this? Put my little hash marks on here. And here was 0, -1, -3, 1, 2, and so on. Now let's say that we had a closed circle like this and an arrow going that way. Now, how would we show that in an inequality like this? See, here is the inequality. Here is the graph of the inequality. Well, we have the graph. We need the inequality. Well, first of all, we identify a variable like x. Identify the number, -1, because that's where the graph begins. Now we have to think. -1 in relation to x, is it greater than, or is x greater than -1, or is it less than -1? Well, the arrow is going this way, saying that -1 is the smallest value. So we have to do it this way. X is greater than -1. Now, notice the dot is filled in. It's not open circle like this one was. This one said 9 is not a good number for x, but any number less than x, or any number less than 9 would be a good value for x. Well, in this case, 1, it's a solid dot, meaning -1 is a good number for the value of x. So we say x is greater than or equal to -1. Alright, so that's a introduction to inequalities. Now, let's solve some inequalities. Let's do a problem like this here. Draw me a line so you separate the two. Okay, 5n plus 6 is greater than or equal to 16. Now you might be asking yourself, how do I solve for this? I know how to solve for a problem that has an equal sign. You would know how to solve for this problem if it looked like this. That would be very easy. You'd subtract 6 from both sides. Well, you'd box your variable first. That's how we start. Box your variable, subtract 6 from both sides. This goes to 0. That gives me 10. And then divide by 5. Like this right here. Giving me n then is equal to 2. That's how we would do it if we had an equal sign. Well, the rules do not change with inequalities. The rules are still the same way. Notice, subtract 6. Oh, I almost forgot. Box the variable. Subtract 6 on both sides. That goes to 0. 10. And gives me 5n here. Divide by 5. And then is greater than or equal to 2. Okay, the only difference between these two is that this right here says that only 2 can equal n, whereas this one says any number that is equal to or greater than 2 is equal to, or is n. So we have to show that using a number line, like this right here. We put a 2 right there. Now, does this get a closed circle like this one or an open circle like the one before it? Well, it's equal to, so it gets a closed circle. Let me change my color here. Closed circle. And we're looking for numbers that are greater than 2. So we're going to go this way. Now let's check our answer. Well, what's the number underneath here? This is underneath the line. 3, 4, let's try 4. 4 is greater than or equal to 2. That is a true statement, so my line is going in the right direction, and I've graphed this correctly. Alright, let's look at another one, another problem. Let's say, let me draw me a line here. Okay, let's try this one. 7 is less than -6n minus 5. Okay, if we assume this was an equal sign, here's what we would do. We would add 5 to both sides. Oh, we would box the variable first. I keep forgetting to do that. We box the variable so that we remember to move everything that is not inside the box over to the other side of the inequality, or the equal sign. Alright, so we do that. We know this goes to 0. This becomes 12. Okay, bring down the inequality. Now bring down the variable. Now the next step is to divide by -6. Okay, so we divide by -6 on both sides. Now if you remember, I had said that the rules for solving for inequalities and equal signs are exactly the same. Well, that wasn't entirely true. There's only one rule that is different, and that is when you are dividing or multiplying by a negative number. Notice that we are dividing by a negative 6. Now, because we're dividing by a negative 6, this inequality gets flipped, gets reversed. It's a less than right now. It says 12 is less than negative 6n. When we divide by a negative or multiply by a negative number, it switches so that now it should read as a greater than sign. 12 divided by negative 6 is a negative 2. This goes to 1, leaving me with just n is less than negative 2, or negative 2 is greater than n. Now, how would we graph that? Well, we would draw us a number line, just like this. Put our marks down. Negative 2, find us a negative 2. Let's say that's going to be negative 2 right there. Okay? Now, the sign is not equal to, so that means we're going to have an open circle on negative 2. Now, the question is, which direction should we go? Negative 2 is greater than n, meaning it's the largest number that n will ever be, or could be. So, negative 2 is the largest number. On this side, we have negative 1, 0, 1, 2, and 3. These are all larger numbers than negative 2, so the line has to go that way. Now let's check it. Negative 3, negative 4, negative 5. Let's try negative 5 here. Plug it in for n. Negative 2 is greater than negative 5. That is a true statement. So then we have graphed this correctly. All right. That concludes our discussion on graphing, well, inequalities. Solving for inequalities and graphing them.